Good day. So in my problem, it's problem 9.3 under the topic deflection. So determine A, the equation of the elastic curve for the cantilever beam AB, then B, the deflection at the free end, and the last problem, the slope at the free end. So in finding the elastic curve, we have the formula EI d squared y over dx squared equals m to the x. So first we will find the moment equation for this beam, and then we will cut the beam in any point. So let this distance from the free end is x, so the other part will be x minus L. So either of the both, you can use which part in order to find the moment equation. So here, I'm going to take this first part and draw the section over here. So the load was W0 x over L because it is at a distance of x. So if you cut the beam over, there will be a shear force here, and there will be a bending reaction or the bending moment. So let this point be J. So next is we will find the equation of moment for this beam. So sum of all moment about point J is equal to 0. So as you can see, the load is uniformly increasing. So finding the moment equation, we will convert it into concentrated load. So the load will be W initial x over L times x over 2 because it is a triangular load, and it will be acting at a distance of x over 3 up to point J, and the total length is x. So from the summation of all moment to put J is equals to 0, m plus WO x squared over 2L times x over 3 is equals to 0. So m plus, it's because it's a counterclockwise. The direction of the deflection is counterclockwise. I mean the bending. So simplified equation, we have m is equals to negative 1 over 6 times WOX cubed over L, and that is the moment equation. So we'll combine this formula in order to find the equation of slope and the deflection. First is we integrate it. So it's EI dy over dx is equals to negative 1 over 24 W initial x 4 over L plus C1. That's the first equation. And integrate it again to get the equation of the deflection. So EI times y is equals to negative 1 over 120 W initial x 5 over L plus C1x plus C2. And that's the second equation. So we will apply the boundary condition. So x is equals to L, dy over dx is equals to 0, and substitute this to the first equation, and we get C1 is equals to 1 over 24 W0 L cubed. Next is the x is equals to L and y is equals to 0, or I substitute it to the second equation, and we get C2, which is negative 1 over 30 W0 L to the power of 4. Then next is put C1 and C2 to the equation 1 and 2. So for the elastic curve, we will use the equation 2. So y is equals to negative W0 over 120 EI times L times x to the 5th minus 5L 4x plus 4L5 to the power 5. That's the equation of the elastic curve. As we find the deflection, so y at the free end, so x is up to 0, so we will substitute this to this formula, and then we get negative W0 for L to the 5th over 120 EI times L. So simplify, we get YA is equals to negative WOL4 over 30 EI, and that's the deflection. Deflection is negative because it is downward. Find the slope at the free end, so it's theta A when x is equals to 0. So we'll substitute it to the first equation and then simplify the equation. And then we get theta A is equals to WOL4 L3 over 24 EI. It is positive, meaning the direction is counterclockwise. So that's all. Thank you.